Alright, here we have a problem called Roman to integer, and we want to translate from Roman numerals to integers. These titles are generally very self-explanatory. But yeah, so basically we have the rules here of how Roman numerals get converted to integers. Certain symbols get mapped to certain values. Generally, you just add them all together, and they're written. They're typically written from largest to smallest from left to right. That's what it says. Okay, here's my mouse. Yeah, usually written largest to smallest from left to right. So if it's and if this is the case, then you just add up all the numbers. But there are some cases where you will actually have instead the next number, instead of being smaller, will be larger. And if the next number is larger, then the current number, you subtract it instead of adding it. And this goes over, like, there's only like a few scenarios in which this could happen. But yeah, so if you have if you have an I before a V, then it becomes 5 minus 1, which is 4, rather than 5 plus 1, which would be 6. Similarly, I can come before X, but yeah, basically, yeah, there are a few scenarios in which you can have a smaller. There are a few scenarios in which you can have a larger symbol come after a smaller symbol, in which case the smaller value gets subtracted. And basically, given this information, we just want to convert to an integer. So basically, with this problem, the key is really just understanding the process of how this works. And once you understand it, it's pretty straightforward to like write up in code. But yeah, so it's basically, so we have this list of how to convert symbols to values. So we have a list, so this Roman numeral, we can just go through and convert all the symbols to values, but we have to add in this extra logic for checking if we need to subtract rather than add. And the only thing we need to check is if the next symbol has a larger value. We don't really need to worry. So that's the thing with this problem, is that we don't really need to worry about like the exact cases. Like, we can assume that, let's see here. Is it actually written explicitly? It is guaranteed that S is a valid Roman numeral in this range. So because it is a valid Roman numeral, we don't have to worry about like specific like edge case, like you don't have to worry about like what would happen if to your code if you had like an I come before an L or an X come before an M. Like if you were dealing with like general like symbols, then these are things that maybe you would have to think about. But here, because we have valid Roman numerals, all we care about is whether the next symbol represents a larger value. And so that makes our lives easier. Okay, so let's actually see what this would look like. Okay, again, I'm going to rate this by hand because it helps me learn. So first, like this information unfortunately needs to be hard-coded in. So we'll have some dictionary which converts the symbols to ints and integers. And so, of course, it's just I will get mapped to 1, and then blah, blah, blah. Eventually, we'll end with M, get mapped to 1,000. I'm not going to write all I'm not going to write it all out by hand. I'll type it all when we get to that point, but I'm not going to write it by hand. But yeah, so basically you have a dictionary that encodes this information so that you can, the keys are the symbols and the values are the numbers here, the values. Okay. All right, so now we're going to go through and get the total sum, or just the total value. So the total, we're going to start it at 0 for I, symbol in enumerate S. So I is going to be the index that we're on, and symbol is going to be the actual symbol that we're on. Okay, so we're going to record what the current value is. And that's just going to be, so we know what the symbol is, and we just need to convert it to an integer. So we're going to use our dictionary. We have symbol to int, and we're just going to input the symbol. And actually, with how this code is written, it would actually be faster to just do symbol to int of s of I. Like, I think that would be shorter, but like, you know, this allows us to use like the enumerate function and everything. Like, this is fine. Don't worry about it. Just interesting to note that like oftentimes this using this part of the enumerate can make our code simpler. This time it doesn't necessarily help us like a ton. Okay, anyway, so that's the current value. And now we need to check if the next value is, we need to check if the next symbol corresponds to a larger value. So the first thing we need to do is we need to check that this is something that's actually doable. So we need to make sure that there actually is a next symbol, which is true if I is strictly less than the length of S. Is this right? Pretty sure we have to subtract 1. I think I have a typo in my notes. Yeah, because the final index is length of S minus 1. Because that's how because indices start at 0. So the final index is length of S minus 1. And so we're only guaranteed to have a next index if the current index is strictly less than that final index, which is length of S minus 1. Okay. And I'll write it on the next line. Actually, we might int. So now we need the next value. And if this next value is strictly greater than the current value, so if this happens, then we're in the special case where we have to subtract the current value. So in this case, total minus equals current value. Otherwise, we're in the normal case in which we just add current value. And by the way, once we get to the final index, this means well, actually, let me talk about this if statement after I've written everything. But yeah, after we've done all this, we just return the total. Okay, what else was I going to say? So here, so it's worth thinking about how we did this. So if I is strictly less than the length of s minus 1 and this. So basically, like, it's critical that this part comes first, because if this part were to come first, then when I is equal to length of s minus 1, this is going to crash the code, because this is only valid if this condition holds. And so it's critical that this comes first and then this symbol, or then this this clause, checking that this value is strictly greater than current value. Well, you could, if you wanted to, like, separate this into like a separate if statement, but that would, you'd have to make sure that you're always like adding the current value in all the other cases, or in any cases that are introduced. And then there's also, I guess the one thing that would be nice about that is that, like, you could actually, like, we have current value equal to this. You could define a variable called next value, which is equal to this, and then just have if next value is strictly greater than current value, then total minus equals current value. So that would work, but it would be more lines of code, and yeah, this part works well enough, so this is perfectly fine. And trying to think if there's any other edge cases or any other things that we need to keep in mind or take note of. It is worth noticing and being aware that what happens once you get to the final index, this is automatically going to evaluate to false, and so you're automatically going to add the current value when you're at the final index. And based on the rules, that is completely fine, because, like, there's never going to be a case in which you subtract the final value, because in order to subtract, the condition is based on the value after it, and so if there is no value after it, then it's always going to be added. Okay, but yeah, so this is what the code looks like. So let's actually type it up now. So symbol to int is a dictionary, and I'm going to have to just write it all out. Let's see here. I don't know, I'm a little, ooh, this is not how you code a dictionary. Wow, okay, cool. Right, I know how to code, I promise. But yeah, so I'm using single quotes. So I think there's certain, like, conventions in Python where it's better to use double quotes just consistently. I don't know, but then also, like, generally, it seems to be a convention that with working with, like, data frames, like if you're working with data, then it's very common to put column names in single quotes rather than double quotes. And so I've gotten used to doing that, and then that sort of permeated into some of my other coding, but it doesn't really matter. Single quotes and double quotes serve the same purpose. I don't know, it's just something possibly worth thinking about. So try symbol in enumerate. So we started the total at 0, and we're going to loop through all of the symbols in S. I'm going to set the current value to be the current value. You basically take the current symbol and you look up the corresponding integer. Now, so here we're going to determine whether or not to subtract or add. So if I is sufficient, if we're not at the last index, and symbol to int si plus 1 strictly greater than current value. So if the next value is strictly greater than the current value, total minus equals current value. Otherwise, I'm going to add the current value. Then we will return the total, right? And so long as I didn't mess anything up, this will work. It's a vacuously true statement. Yeah. So there we go. That's how we do this exercise. So the actual writing out of the logic wasn't too tricky here. The most important part was really just like reading through the problem statement and really making sure that we understand the rules of how Roman numerals work, and understanding that you just add everything together, except in the case where the next symbol corresponds to a larger value, in which case you subtract it. And that is the only thing that you need. You don't need to specify like these 6 specific cases. All you need is check if the next symbol gives you a higher value. And that's how you do this exercise.